Okay, good afternoon, good evening. I think we are going to start now, and see if there are other aspects of maybe research methodology that people would want to know. You can just type them there in the chat box. Then it will inform other aspects of issues that we might need to cover going forward. So what we are going to do today is to look at some fundamentals of quantitative data analysis for those of you who are interested in doing quantitative research. So, like I said in the series that we covered, this triangle is very crucial. When you look at your philosophy, when you look at your design, and when you look at the methods, and we are now focusing on a quantitative research method, specifically looking at how do we analyze and interpret quantitative data. So this interconnection is a critical interconnection for people who are doing research, and people should be able to understand the interconnectivity of all this. So when we are doing analysis for quantitative research, you need to know that when we look at this, quantitative research is more fixed in its approach. It's more concerned about following systematic procedures, following fixed aspects of doing things. So even when you are writing your proposal, it's very important for masters and doctoral students to indicate how data is going to be analyzed, especially if you're doing quantitative research, or even if you're doing qualitative research. What kind of statistics are you going to use? What kind of descriptive analysis is going to be performed, and all that. So assuming you have done your research and you've collected your data, and you now need to run the analysis, I'm going to go through some steps that are crucial in doing all that. So the first step that you need to do is to report about the sample. What are the characteristics of this sample? What is the response rate? What is how many questionnaires were distributed to your audience? So if you are to do that kind of stuff, you need to make sure that you are in a position to know how many questionnaires have you distributed, and how many were returned back, and all that. So you would find this is my work, that is work in progress. So in all, what I'm saying is, if you can see this paragraph that I have tried to highlight, let me increase the font. It's missing down there. So you would find out that in this study, a total of 500 questionnaires were distributed, and I cared to indicate to my audience that these questionnaires were actually in English. They were administered, and as a result, I got 450 of them filled back with usable responses. So you would need also to know that when you are doing your collection of data and all other stuff, there are questionnaires that can be filled, but not all of them are usable. So for a questionnaire to be completely usable, it must be completely filled with the information that you need to do. Don't get into a habit of filling some gaps that were left by respondents and then you try to complete it and say, oh, okay, let me just complete this. That's not going to work. So it's important to indicate the instruments that the number of questionnaires that were distributed, and how many were returned back, and how good was your response rate. So in this regard, you just need to say 450 divided by 500, then you will be in a position to get your response rate. And as you do this, it's quite important as a researcher. It's quite important as a researcher that you present this kind of information. You present this kind of information in a table format, showing that this is what you distributed, this is what you received back, and then this is your response rate. So you present that kind of information in a table. So when you have done this, so this is the initial step that we normally do when we are doing quantitative analysis. You need to report about the sample, you need to report about the sizes. So in addition to reporting about the sample, you also need to indicate this kind of description of the sample. This is how we report the sample. So in this study, I am actually reporting the sample in this kind of paragraph, where I am saying that the majority of respondents were women, that is 56%, and were seniors, that is I'm talking about their age. So in all this, I am reporting, I am describing the sample of my study. So the reader would understand that I collected data from both male and female, but the majority were female, and the majority of my respondents were seniors, and the majority of them indicated that they come from Africa, and followed by those that come from Europe. I also indicate that 51% of them had a degree or a diploma. They earn around US 1,500 after tax in a month. And they were visiting Zimbabwe for the first time, traveling in a group size of 2, staying in the country for 2 nights. And the majority have heard about this destination using word of mouth recommendations. So then when you get that, so this is how you're gonna present the data for your sample. So you would need now to identify the key characteristics of the sample you are looking at. So you need to indicate the gender of the people, the age of the respondents, where they are coming from. They are coming from Asia, Africa, North America, South America, Europe, the Oceania, those with no school, who have never gone to school, those with non-degree qualifications, those with diploma degree qualifications. Then, so you would now need to indicate how many were these people and what's the frequency. So in terms of this study, you would find out I have 252 who were female, and they constituted 56% of the sample whose data I analyzed. So that's how we're gonna present this particular kind of data. And this is the first step that we need to do. It just gives you a sense of what kind of data do you have, what kind of information can you quickly gather in terms of this. So this is normally presented in a table, and that's the first step for data analysis in that regard. So when you have done this, then the next thing that you might need to think about, of course, many researchers, they don't do that, is to look at which method did you actually figure out whether there was a response bias or not. So you need to discuss that particular method in terms of your response bias, and also indicate if those people had responded, what was going to happen to your survey estimates? Were they going to be different? Were the results going to be substantially changing? It's critical to know all that. So by bias, we are talking about if non-respondents have responded, were the results going to substantially change? So you can actually do that by doing what we call wave analysis or a respondent analysis, a situation where you can simply call the respondents to find out, engage the nature of their responses. This can show you whether what they would have said is going to be substantially different or not. So you can do this, but it doesn't really matter. But it's one of the steps that you would need to do after coming up with those descriptive results in that regard. So that's the second most important step. Then the third most important step, which I often find in most proposals that I have listened to when they are being defended, most proposals that I have examined, and many other stuff, is the people really think that descriptive design is a good design. It is a good design for undergraduate students who are trying to get a sense of what research is all about. So they can stick to a descriptive design where they can simply describe the results, describe the results, and it ends there. So the third step that you would need to do if you are to do rigorous and meaningful analysis of quantitative data is to provide a descriptive analysis of the results. What is what do you, are you what why if you are you in a position to describe what these results mean, and you also need to make sure that when you are doing this, you are covering all the independent and the dependent variables, the predictor and the predicted variables. They all need to be covered. So normally, if you in your study you have only generated the means. The means is all you have. You have only generated the means, the standard deviation, and many aspects around that. Then what it would mean is it would mean that you are simply focusing on the descriptive descriptive results, and descriptive results are not very good results, because what you are simply saying is you are simply describing what you have obtained there, and they don't really give us so much information for people who are doing quantitative research at a higher level, like at a postgraduate level. So in this, we are simply saying you are using the means, you are using the standard deviations, or a range of scores to describe the independent and the dependent variables. And this is the reason why I'm always mentioning this to those who have attended maybe presentations at the business school, where I would say a descriptive design is a weak design, because you are simply describing that 56 of my people were women, 10 of them had a master's degree, 5 of them had no school, 15 of them are from Namibia, 10 of them are from such and such a country, and that's it. It ends there, and you don't get a good sense of what does this result mean? Can we generalize it? What inferences can we make from this? So descriptive designs, of course, we are going to cover some issues of research designs at some point when we get time. But descriptive designs are not good enough for masters and doctoral students. Descriptive analysis, it's good as part of the package, but ending at descriptive analysis is not good enough for students. If you have smaller number of participants, what it means is you will not have enough information, you will not have enough data to run more meaningful analysis in the process. So to just go back to that paper that I said is still work in progress. All this information that I'm sharing on the screen at the moment, these are part of descriptive results. that you need to do when you are offering your analysis of quantitative. So you need to give us some descriptive results in the sense of frequencies, these frequencies, percentages. You can also go on to give this mean. So this mean is part of descriptive results. All these are descriptive results. I cannot really infer anything about this mean except I am describing this factor with that mean. I am describing this factor with that mean, and all that. So it's quite important for people to make sure that they go beyond descriptive results. I think this is another study. Let me see if I can find some more descriptive results that I can show you. Right. So this is also another descriptive results. I am simply talking about the gender, the age, the program that these students are studying, and it ends there. And it doesn't give me a lot of stuff. And the same comes here when I have these means, these standard deviations. They don't mean more than simply describing the situation that I have in this particular table. So it's critical that we understand that step and we take it forward. So if you have a smaller number of participants, I think in the previous efforts we highlighted that we need people to make sure that they collect data from large samples. If you are to do proper analysis of quantitative results, you really need larger samples. And these days, people are talking about 1,000 plus. So you need to collect data from 1,000 people, 500 people, for you to be able to run meaningful analysis. For instance, if you are to do structural equation modeling, you need a minimum of 230 people who would have completed your survey and give back to you the information that you would need to have that. Then after you have done this, the next step is if your instrument, I'm sure most of the people, they use instrument with scales, instrument with scales. Find out if I have an instrument here, demand instrument. Okay, let me see. Victoria Falls. Okay, yeah, I have one. So I'm just going to open one instrument, then I will show you the information that I'm talking about. So if your instrument has got scales, if your instrument have got scales, then what it means is you would need to collapse those scales, or to make sure that those scales are reduced. So you need to do a process what we call scale reduction. Victoria Falls, where did it go? Demand. Just give me one moment there. Okay, Victoria Falls. Right. So while it is opening, all I'm saying is when you are doing this, you need to make sure that you are in a position to come up with scales. And if your instrument has used the scales, then you must be in a position to make sure that these scales can be aggregated together these scales can be collapsed together so that you formulate what we call factor analysis. What is wrong here? It's not opening. Okay, let me open it. Okay, somehow my instrument is taking time to load, but all I'm trying to say is, if you have developed your instrument, and in your instrument you have got things like you have used a Likert scale to measure quite a number of elements in your instrument, then what it means is you need to conduct what we call exploratory factor analysis. And the reason why we conduct this exploratory factor analysis is to make sure that we do data reduction. Because, for instance, in one element, you might find out you have measured a single construct with 27 items. And in those 27 items, we need to get a sense of how do we group these items together so that it becomes what we call a factor and all that. So if you are to go into one of these examples, so for instance, I'm going to share this screen here and show you what I'm talking about. So you look at this this paper I'm working on. We are trying to just understand the influence of course experience, student satisfaction, and how does it influence student re-enrollment for master's degree. How does it influence word of mouth recommendations? So all I'm saying is, in this particular section of my instrument, I have asked the respondents a number of aspects in my questionnaire and all that. So for me, what I did in this is we were just asking, were the lecturers extremely good at explaining all these? Lecturers worked hard and what? But this thing that is in black here did not emerge from the instrument. We wanted to measure certain things, but when we collected the data, what it means is our data or our questionnaire had questions on 1, 2, 3, 4, 5 aspects that we have grouped now then, and all those other aspects, if you take off the black one, that is what we asked. So, but when you run your factor analysis is going to help you to cluster things that mean more or less the same stuff together. And this is what would have happened in the one that I have highlighted, to say, oh, okay, all these elements that we have asked our respondents, they all measure the idea of course experience. Then all these elements, they all measure the idea of student satisfaction. All these elements, they measure the idea of student loyalty. All these elements, they measure the idea of student word of mouth. All these elements, they measure the idea of re-enrollment intentions. Right? So when you are looking at this, you would have your questionnaire with 40 or 50 elements that are not grouped. But when you run your factor analysis, it is going to help you to group these factors together for further analysis. So when you are running the factor analysis, there are some issues that we need to observe. There are these issues that we call factor loadings. So all the factors that are important for analysis, they should at least load above 0.5. So 0.5 is the minimum loading that is recommended for that element to be considered a good element. So it needs to load at a minimum of 0.5, and they normally load on different factor structures, and it's your responsibility as a researcher to make sure that let's say the course improved my skills in written communication loaded in 3 places. It's your responsibility as a researcher to make sure that you choose this element and cluster it in a factor that would make that would make a lot of sense. So in that regard, so that is one element that you need to do. Then the other element that you need to do while you are there is to make sure that you be in a position to measure what we call the reliability of these factors. How reliable are these factors in measuring what they are supposed to measure, internal consistency and all that. So for you to be able to do this, you need to run what we call reliability analysis. And this reliability analysis is done using the Cronbach's alpha coefficient. That is what you use to run that. And for the factor to be considered reliable, for the element to be considered reliable, then what it means is you would need this element, this factor, to load at least above 0.7. It needs to load at least above 0.7. If it doesn't load at least above 0.7, then that factor has to be deleted because it is not internally consistent. It doesn't help you to do a lot of stuff in your analysis. So it's the same stuff that you would find also in this particular article. You need to make sure you have that kind of thinking. So this is the alpha coefficient. In this one, it's presented differently because this used a different analysis. In the other paper that I was telling you, we used partial least squares with the structural equation modeling to do the analysis of our data. In this one, I used regression modeling. But for you to before you go to regression modeling, you first need to identify all these factors, and they must load in a situation that is that supports factorability. So for factorability to be supported, there are elements that we do consider in our analysis. The first one is the sampling measure, which is given by what we call the Kaiser-Meyer-Olkin. It's a measure of sampling adequacy. If it is below 0.5, then it means that the sample that you have collected data from is not adequate for you to do meaningful, proper quantitative analysis. So you need to check that. Then the other one is the Bartlett's test should always be significant, and it's significant at a p-value of less than 0.000. If you don't get that, then what it means is factorability is not supported. And for all these to be considered factors, they must load at an eigenvalue that is greater than 1. If they don't log at an eigenvalue greater than 1, then what it means is these factors are not really good enough for you to do the analysis. So it's important that we get that that idea on point. Otherwise, our analysis of the data is going to be affected with that. So they must log at an eigenvalue that is greater than 1. If it's not greater than 1, then it means we need to drop that. Usually, if you are running these things in SPSS, there is what we call a scree plot that should appear, and a scree plot will give you that all these factors you've loaded below 0.1, and all these other factors you've loaded below 1, and all these other factors have loaded above 1. I think I have one more paper there that has got that scree plot. So this is a paper on ICT that we published in January 2020. So if you go down there on it, we were measuring perceptions of ICT students in Namibia. So you will be able to generate something like this in your analysis. And when you generate something like this in your analysis, this is a script wrote. So it's going to tell you which of the factors are useful for factor analysis. So it will show me that this factor, that other factor, where there is a node, these are important factors because they have loaded at an eigenvalue that is greater than 1. So it's quite important that we take that point on board. So most of the instruments that we use in quantitative research, they have scales. You are asking people closed-ended questions with a scale of 1 agree or 1 disagree to strongly agree. And it is from those scales, as long as you use a number of elements to measure certain aspects, certain constructs in your study, it is important that you reduce your data through factor analysis. You do data reduction, you do data summarization through factor analysis. You collapse these scales through factor analysis, and then after collapsing these scales, you must run reliability analysis of those scales. And like I said, the reliability must be a minimum of 0.7 for it to be reliable. Anything below 0.7, it means your instrument was flawed. It means what you are trying to measure is not exactly what the instrument collected. Then you might need to revisit that kind of idea and all that. Then the fifth step. So after doing your factor analysis, you have reduced the data into what we call factors. And if factorability is supported by these statistics. The first thing is the factors have to be reliable, a minimum of 0.7. Secondly, those factors, they should have loaded at eigenvalues that are greater than 1. Thirdly, the loadings of each factor item, each factor element should be a minimum of 0.5. Number 4, these factors, they must be, apart from reliability, they must congregate. They must not cross-loaded. If they have cross-loaded, it's your responsibility as a researcher to determine where does this factor belong, or where does this item is best described and that. So the eigenvalue is important, the loadings is important, the minimum reliability is important. Then the sampling adequacy should be greater than 0.5. If the sample is not greater than 0.5, then it means that sample from which you collected the data is not good enough, and the Bartlett's test of sphericity should be significant at P is less than 0.00. Otherwise, if that is not done, then it means it's not going to work. Welcome, Dr. Mare. There, he was a little busy, and he has joined us. Are you hearing me? Dr. Mare? Okay, so these things really requires a lot of us to have some kind of understanding and many other aspects. So the fifth step now is after conducting your exploratory factor analysis, you can now then go into some deeper analysis of the results, where you would need now to run some inferential statistics, where you need to run some inferential analysis in your study. So step number 5 in quantitative analysis is you need to identify the statistics. And perhaps at this level, you would have identified the software, whether it's eViews, it's SPSS, it's Stata, it's Microsoft Excel that you are going to use to run inferential research for you to answer your research questions and your objectives. So when we talk about inferential analysis, we are looking at you being able to analyze data in such a way that you will be in a position to make inferences regarding the variables that you are dealing with, regarding the groups that you are dealing with, based on the sample that you would have drawn from. And every time you are writing this section, if you are to use regression analysis, please tell us what's the reason for using regression analysis. If you are to run independent t-tests, please tell us the reason why you are running independent t-tests. If you are to run structural equation modeling, you should always provide a rationale for the choice of the statistical test, and you must be in a position to mention the assumptions that are associated with all this. So it's quite important for people to make sure that when they do write these sections, they are able to provide the rationale of why are they doing that, why are they using that kind of analysis, and more importantly. So maybe if I'm to show you a sample, maybe in this sample, you would find out that let me see if it's yeah, it's there, right? So if I can increase the font here, you would find out this is a section that talks about exploratory factor analysis. It's a statistic that we selected to use in the study. So in this example here, I am giving the rationale of why we used this. So we are simply saying exploratory factor analysis was used in this study as a means of identifying a smaller set of variables that can be used for further multivariate analysis. So we use the factor analysis in order to do data reduction. So there must be always a way of providing the rationale of why was that used, why was that used. If that rationale is missing, then it means part of your analysis is also not very good enough in order to do a number of stuff. So it's actually very important for you to indicate what kind of statistic you are using and what's the rationale. Why do we need to use that kind of statistic in order for us in order for people to understand the analysis that you are doing. So it's quite important that people provide a rationale. And like I always say, even when you are writing methodology, even the methodology section in the proposal or in the chapter, everything that you write in methodology requires some kind of justification. What's the rationale? Why did you choose this? Like, for example, why did you choose probability sampling? Why not non-probability? Why did you choose this statistic? Why not the other one? So you should always be in a position to give them what is it called? To give a justification. So don't just mention that I'm going to use regression analysis, I'm going to use chi-square, I'm going to use factor analysis without providing a rationale. And you must also consider whether your scores in your sample, are they normally distributed or not? Because this influences the kind of statistic that you are supposed to use and not to use. And most of the times, like for example, when people are running correlations, most of the times people use the Spearman's rank correlation wrongly when their data is not, when their data is actually not normally distributed. and when their data is normally distributed, they use Spearman's rank correlation wrongly, because it's not the correct tool for normally distributed data. Dr. Mare?
Yes, how are you?
Hey, I'm good. You are free to chip in here. We were just starting.
No, you can go ahead. I will chip in towards the end. This is your forte, so I will let you go ahead.
Oh, okay. Right. So in this table, I just tried to do some basic statistics and show each other how we're gonna move forward. So let's say the nature of you. So when you are doing analysis, you need to go back and think about what is the nature of the research question. What does the research question requires you to do? What does the research question requires you to do? Because that is very critical in the choice of the statistics to use. What is the nature of the research question? What is the nature of the research question? That is very critical, as it influences what are you going to use. So if the nature of the research question is worried about you making group comparisons, comparing male with female, comparing undergraduate with postgraduates, comparing primary school with high school, and you have got one independent variable and you have got one dependent variable, and there is no covariance, and then the score type regarding your independent variable and your dependent variable is categorical, or it could be continuous, and the distribution of your scores, they are normally distributed in that belly curve, then the statistic or the statistics that you should use to analyze that particular data, if the research question is worried about comparison of groups, then you are free to use T statistics. Most of the times people use statistics that doesn't answer the research question. So when you are thinking about when you have formulated your research questions, it's critical for you to go back to the research questions and try to understand, what am I measuring? So if you are measuring group comparisons, then it means you can use a T statistic. And a T statistic, it only compares two groups, male and female, undergraduate and postgraduate, high school and primary school. It doesn't go beyond that. They only have to be two. So if you find yourself comparing three more than two, then and you use T statistics, that's a situation where we will say that your whatever you are analyzing here is something we don't understand, or something that doesn't contribute to answering of anything. Then if the nature of the question is still group comparison, but you have got more than one independent variable, and you have got one dependent variable, and you don't have any covariance, and your data is categorical and it's continuous in nature, and your data is normally distributed, your scores are normally distributed, then you can also use what we call an analysis, one-way analysis of variance, where you will be able to compare more than two groups in terms of outcomes. So if, let's say, if I am comparing I want to understand whether there are significant differences between male, female, and people who are young and people who are old, in the way they buy things in a pandemic. So it means my independent variables is age, is gender, is the level of education. I will be in a position to use one-way analysis of variance, because that will give me an idea to compare the means among different independent variables and see how do they influence a certain dependent variable in that regard. So one-way analysis of variance, you're going to use it when you are comparing more than two groups in terms of their outcomes, and the independent variables is more than one. You can use your one-way analysis of variance. Then if the nature of your question is you have to do group comparison, you have got one or more, and you have got one dependent variable, and in this time you have got a covariate, and your data remains categorical, continuous, and normal. Then in this kind of stuff, you're going to use what we call analysis of covariance. And in this place, you are comparing. It's a comparison of more than two groups in terms of their outcomes as well as the covariates that are in that particular data. You can also use what we call MANOVA, multiple analysis of variance, if you want. But you first need to understand, the idea I'm presenting here is you first need to understand what does your research question requires you to do. And it informs the statistics that you need to use in order to analyze your data. If you are worried about association between groups, you have got a single independent variable, a single dependent variable, your data is categorical and continuous, but it's not normally distributed. That's where you're going to use chi-square analysis. The data, the scores around your sample should be not normally distributed. Then you're going to use chi-square, and what it yields there is it's going to give you information about the association between two variables that are measured by that particular category. Furthermore, you can also look at the relation of variables. You are relating variables. You've got one independent variable, one dependent variable. Your data is continuous in nature. It's normally distributed. Here you can use the Pearson product moment correlation. Get it right. Most of the times people use this correlation and the other one wrongly. This one is used when your data is normally distributed. The other one is used when your data is not normally distributed. We call that one the Spearman's rank order correlation. And they measure two different aspects regardless that they are correlation statistics. So this one tells you the magnitude and the direction of the association between two variables. The other one tells you the strength and the direction of the association between your variables that you are measuring. Two different statistics requiring two different distribution of data. So people need to be careful there. So if you are to relate more than two independent variables with one dependent variable, then you need to look at what we call the multiple regression. Multiple regression. If you have got one variable and one independent, one dependent, you can use just linear regression, the simple one. But if you have got multiple independent variables, you have got age, you have got gender, you have got education, and you want to find whether gender predicts, let's say, repeat business, you run that regression on its own. So with multiple regression, you are simply saying you are running regression modeling multiple times. For each independent variable, you run the analysis. For the next independent variable, you run the analysis. For the other independent variable, you run the analysis. So what we are trying to achieve here is to learn the relationship between several predictor variables, several independent variables, and how they predict on an outcome variable. So it provides you with a relative prediction of one variable among many in terms of the outcomes. So these are just general aspects that you would find, and you need to understand to understand all that. So like even in the work that I said, it's work in progress. Do I see where it is? It's work in progress. Where is that runner paper? Okay, even this one, what we did in this one is we had to run multiple linear regression. So what we are saying here is for us to find this was a factor that we identified. So we are now looking at how does lack of ICT literacy predict implementation of an ICT policy. So we are taking this factor and run it differently. And we are running multiple levels of regression analysis in order to identify the results. So I would run this regression analysis, get the results, put it there, run the second level, run the third factor, run the fourth factor, run the fifth independent variable in order to do all that. And even when you run your regression analysis, we also want you to calculate what we call to determine collinearity in your statistics, so that we get a sense of whether the ideas or the issues that you are measuring, are they not really happening because of chance. So it's actually very important for people to look at that regard and do some proper analysis. Then the last step of doing this, I didn't cover all the statistics. There are a lot, but I have covered the basics ones. And what is more important is you need to know what's the nature of your question, the type of the data you have, whether it's normally distributed, then you decide on the statistic. If you look at those characteristics, they should help you to decide on statistics. Then the final one is for you to present the results. Results are presented in tables and figures. They are not analyzed in tables and figures like what we read most of the times. Most of the times we read people writing, my data is going to be analyzed using tables and figures. You don't analyze it using tables and figures, right? We present data in tables and in figures. And after presenting that particular data, you must interpret the results from these statistical tests. What do these results mean? So interpretation means you as a researcher, you are drawing conclusions from the results of the research, for you to be in a position to see whether you are answering the research question or not, and you are providing a larger meaning to the findings you got. So when you are interpreting your data, there are two major steps that you need to know. The first one is to report the results, how the results answered your research question or the hypothesis. So you need to give us an extensive description. You need to state the statistical significance of the test. You can also give us the confidence intervals. In these days, people are getting worried that the p-value is becoming abused. So as a way of not to abuse the p-value, you also need to give us some effect sizes around all that. And this will help you to clarify the meaning of the results. And significance reporting is done to show whether the results you have, if they have not happened by chance. So statistical results are significant if the results are unlikely to have occurred by chance. And you need to determine how these results are significant. At what level are we looking at this significance? So we normally use the p-value at less than 0.5, less than 0.001, and it's important that we get this. So when you are reporting your results, this what I've put in bold is the way we write. So the analysis of variance revealed a statistically significant difference between undergraduate and postgraduate students in terms of attitudes concerning online learning. Then you go into your results, you take the results that support this statement, and the results is your F ratio there, 2.6 equals to 8.5, and it's statistically significant at that point. So this reporting is very crucial in all what we do as people whom who write these results, right? Like if you look at this, where I am highlighting the results generated in an overall multiple R squared of 0.683 and was statistically significant. And I indicate by how much was it statistically significant. This is very important when you are reporting and when you are interpreting your data. If you can't do that, then it means you perhaps understand little about your results. So it is important that you report these things, even including the effect size and the confidence level. With confidence level, we're simply looking at a level of uncertainty around an estimated observed score. For instance, 95% confidence level, it would imply that 95 out of 100 times the observed score will still fall in this range. So it's actually important, people, to do that. Then the second step is when you analyze your data, you need to discuss what is the implication of these results. So if you just say your results are statistically significant, that's good, but that's not good enough. We need to understand, what does that mean? What is the implication of this result to practice? What is the implication of this result to future research? What is the implication of these results? What are the theoretical implications of these results? What are the practical implications of these results? So you should be in a position to show whether your research question is answered, or your hypothesis is answered. So it's actually very critical for people to be in a position to do all that. So if you can read a lot of these, you must be able to. So like if you can read this, where I have highlighted in blue, I am talking about literacy as a predictor of perception, and I've given you the statistics. And based on this, my second hypothesis was supported. Based on this, my second hypothesis was supported. It's now me, the author, trying to interpret and make some theoretical conclusions around this. And then I would go on further to show you what's the implication of this, by saying that if we want to implement ICT policy successfully, it requires universities and players to increase the level of ITC literacy among lecturers and students. This bit is very important for people to analyze when they're analyzing the data. If those aspects doesn't come out, then it becomes very difficult for people to see how these things work. I think for today I've been talking a lot. Dr. Mare, you can chip in. You can chip in for now, and I think for the basics I have covered, or I thought we can cover. Dr. Mare.
Okay, thanks so much, Dr. Woyo, for such an interesting presentation that you have just made. From my side, I think the most important thing that I just want to say is that I think we need to as quantitative researchers, I think we need to know that we need to adhere to probability sampling techniques, as you were pointing out, so that you can be able to then speak of representativity, but also then you can also be able to generalize your findings. So those, I think, are the most important things that come with being a quantitative researcher. And also, I think also you need to make sure that you know how to run your inferential statistics, so that you can be able to arrive at conclusive results that can actually speak something in the real world. So for me, I think quantitative research actually allows us to do a broad brush in terms of understanding the landscape, understanding what really is happening. For example, right now, if we want to understand, for example, how people are feeling and actually, behaving under this particular, COVID-19 lockdown and restrictions. Therefore, if you want to do a research that can actually give us a broad view in terms of an eagle-eyes view in terms of what is really happening, I would say that a quantitative research would actually give you a better way of actually looking at it. And also it would, even in terms of quantitative data analysis, I think it would also give you much more, concrete, findings in terms of how we can then intervene in that particular order. But I think if you want to do small scale, as we were saying previously, if you want to do small scale studies where you are pretty much probably interested in understanding what actually happens in an organization, probably made up of 10 to 20 people, and in that regard, I don't think doing a quantitative study would really help you. But I think more focused more focused groups or in-depth interviews with those people pretty much would give you much more solid information in terms of what is really happening. So I think we need to look at how this issue in terms of quantitative data analysis can actually be an important tool that we can actually use to enrich our researches. And I know most of the students usually are afraid of statistics, and people usually want to run to the spaces where they are more comfortable with. But based on what Dr. Oyo is actually pointed out right now, I think you and I can actually tell that if you can be able to use this kind of analysis, it can actually be able to enrich your study. It can also allow you to be able to do a better analysis of your research context. So in a nutshell, that's what I would want to say. I would just want to say, if there are questions, I think we are going to allow people to ask us questions for those who are already using this particular method, and then we can be able to just interact based on that and see how we can help each other to move forward. Thank you so much, Dr. Oyo.
Thank you, Dr. Mari. I don't know if there are questions people can go ahead and ask. I see the first question is coming from a qualitative researcher there. So, Dr. Mnangatire, you can go ahead.
Yes, Dr. Oyo. Sorry for a little bit of background noise there. I would like you to come again on a chi-squared test. What are the conditions that need to be met for me before I can run a chi-squared test? The other thing is that I think some of the things you pitched them at a very high level for a starter, especially on factor analysis and on those values, the eigenvalues and the like. But maybe I will need to read and consult you later. But maybe for now, just can you point out something on the chi-squared test?
Oh, okay. When we look at the chi-square test, it's a test where we are simply measuring, let's say we are measuring how expectations actually compare with observed data. And see, like what I was saying in the presentation, I was actually saying that when you do the chi-square tests, in order for you to do the chi-square test, the first point of call is you need to understand what is the nature of your research question. So for you to be in a position to use chi-square tests, the nature of the research question, it must be a research question where you want to measure an association between groups. It must be a case where you want to measure an association between groups. So if that is satisfied, then we move on to the next box that needs to be ticked. What needs to be ticked second is for you to look at how many independent variables you have. If you have gotten in a single independent variable, then it means you can use a chi-square test to see how it measures the relationship between your independent variable and your dependent variable. And your scores must be continuous in nature, and the data must be normally distributed. So for us here, we are just worried about measuring the association between two variables, and the two variables based on the categories that we are looking at. So it's important for us to see what's the nature of the research. So basically, when we are looking at a chi-square test, it's a statistic that measures how expectations compare to actual data or to actual model results. And this data we use in calculating a chi-square statistic, it must be random, it must be raw, it must be mutually exclusive, it must be drawn from independent variables and drawn from a sample that is large enough. For example, you would need probably a minimum of 100 observations for you to be able to run this. So in that, if that element is not satisfied, then it becomes difficult for you to run the chi-square analysis in that regard. I'm not sure if I have answered what you wanted to hear.
Yes, Dr. Oyo, I actually got some very eye-opening things from your explanation. As a roughly, will I be correct if I say age is normally distributed and it's a continuous variable? Then
Yeah,
I can compare it with the performance examination marks, for example, is another continuous variable, which I also assume should be normally distributed. And then I want to measure the association between age and the a score in an examination. Would be something that fits into chi-squared, or there are still some things that are missing there?
No, it does fit there into chi-square.
So I'm a very good student and a very good teacher. Thank you.
Yeah, it does fit there. So the distribution of the categorical variable in the sample is the one that we need to compare with the distribution of the categorical variable in the other sample. So you have your age and I think you said performance and all that. Or for example, we are saying over a period of 2 years, maybe as one like you who works in health sciences, we are saying over a period of 2 years, as a health scientist, you have classified as a health scientist, you have classified the class of women who are aged between this and that to be suffering from self-poisoning as a sample. Then in all that, you can actually run your chi-square tests in trying to compare the groups that you would have. Okay, it looks like nobody wants to ask anything. Let me see the ones that were asked earlier here. Also, there was also a question on whether so reliability is normally measured using the Cronbach's alpha in our in quantitative research. And we have quite a number of things that you can use to measure that. Like, for example, if you are using advanced statistics, like in this case, we were using structural equation modeling to test the relationships and the paths in this model that I'm showing over the screen. So in that, if you want to find out whether that model is actually measuring what it should measure, you need to first to report your construct, your indicator, convergence, discriminant, and composite reliabilities. So there are actually a number of reliabilities that you can actually think of. But most of the times, quantitative researchers are worried about reporting the construct reliability to show how strong are the constructs that they have used in their study, as well as perhaps maybe the indicator reliability is something that you would need to do all that, because what we wanted was to find out how this thing would gonna look in the end, and maybe perhaps to just go there again. One of the things that I'm so convinced that maybe you guys from qualitative research are the ones who are more interested in the elements of too much validity. But if you run your factor analysis, it is also one of the things that we use to report convergent validity in your study. So your factor analysis is also a means of statistics that you're going to use in order to indicate convergent validity if all those other aspects of factor analysis are supported, like the sample is adequate, the Bartlett's test is significant, the factors have properly loaded, and many other stuff. So it's some of those things that we can actually use. When do I report reliability? Is it at proposal stage or at after data analysis? At proposal stage, you would just need to report the kind of analysis that you are likely to do. So at proposal stage, a good proposal stage, especially for data analysis, it would read like the data collected will be analyzed using descriptive statistics, such as the means, the standard deviations, and the frequencies. It ends there. Further analysis will be done using inferential statistics. Then you tell us which inferential statistics you are going to use, and if one of the statistics that you're going to use is EFAs or exploratory factor analysis, you also need to mention that the reliability of the instrument is going to be determined using the Cronbach's alpha coefficient. Then you end there. Then in the final dissertation, in the final article, that's where you need to indicate what were the reliability scores for the information you have collected, because we need to get that bit to see if the scores that you have used were actually the instrument that you have used, was it actually reliable in terms of the constructs that it was measuring. I don't know if I have answered you there.
Yes, I'm satisfied there. I think I've posted another question also.
Okay, what is the role of pilot study in a quantitative research? When we pilot in quantitative research, what we normally want to achieve is what I have posted here. Where did I put it? A pilot study was done before collection. We just want to ensure comprehensiveness in terms of the constructs that you are measuring. Is your instrument really comprehensive? We are worried about achieving readability and clarity and the aspects of content validity. Nothing more, nothing less. Is your instrument comprehensive? Is it readable? Is it clear? Is content validity supported? I don't know whether Dr. Mare is still around. You can also come in and try to respond to that. But those are the key concerns: comprehensiveness, readability, clarity, and content validity. Those are the issues why we would need to pre-test our instrument and see whether it's comprehensive. Are people able to read it and understand it the way you would want them to understand that? Dr. Mara, are you there? Okay, I think he's on mute. What should be included in chapter 3 and chapter 4, which are research method chapter 3 and data collection chapter 4. Is this the standing position of the University of Pretoria? I'm not sure, but in your methodology, you are also supposed to report about data collection, because data collection is part of research methods. So I'm not sure how at your university you normally separate these things, but in a methodology chapter, you are supposed to indicate your research design. What is the design that informed this study and why it should be justified. Then you are supposed to indicate your population and indicate how big it is, especially in a quantitative. We are more worried about that. Then you are supposed to indicate your sampling and your sampling techniques. What is your sample size? How did you arrive at that sample size? Is it representative enough of the population you would have previously discussed? And how have you selected the participants for the sample? So after that, you talk about your instrument. You talk about how the data itself was collected. You also indicate at our university, you indicate this in the methodology chapter, which is normally chapter 3 for master's students. It can be chapter 4 or 5 for doctoral students. Then after talking about the procedure, you also need to go on to talk about you give us a preempting of the analysis that you are going that you have done in the next chapter. So you give us a preemptive space to write about data analysis. Then you write about the research ethics that you observed. Dr. Mare, you can come in and chip in here and see whether at your university it is also different. The idea being asked here is what should be included in chapter 4, chapter 3 and chapter 4, which are research methodology, chapter 3 and chapter 4, data collections. Most universities, they don't separate them, but if they do separate that at the University of Pretoria, okay, that's them.
Yes, I want to concur with you. I think for us, traditionally, chapter 3 is the one chapter that deals with research methodology. So you start from, your epistemological concerns. For example, whether you are being informed by positivism, you are informed by interpretivism. Then you move on to talk about the research design. You talk about your population. You talk about your data collection instruments, and then you tell us about your data analysis. And then ultimately, towards the end, you talk about the ethical considerations that might have affected the whole process of actually gathering that data that you intend to present in chapter 4. So generally, that's what it is, especially at master's and honors level. But when it comes to PhD, I think usually these chapters are not they are not static. It's not like they are cast in stone. They can actually change. You can actually have chapter 5 as the research methodology chapter. You can have even chapter 4 as research methodology chapter, depending on the length and the number of chapters that you want to include in that particular thing. So it depends, but essentially all these things that are called research methodology chapter, it's all these things that we've been talking about since we started this platform. I think all comes and should be part and parcel of what we call chapter 3 when we are dealing with master's students and also honor students.
Okay, so let me see if there is any other thing. So I think maybe, I don't know, in health sciences, Dr. Mnangatire, do you separate these chapters differently?
Okay, I think there are many formations that I have seen. I think this is to do with institutions mostly, because like in some cases you find that you don't have chapter 2. you don't write chapter 2. Maybe that is also more inclined to qualitative research. So you write chapter 1, chapter 2 becomes your methodology, chapter 3 becomes your results, and it becomes the results and the literature together. And then chapter 5 becomes like your implications, your recommendations, and something like that. And in some cases, it may, yeah, that's what I understand. But normally, the standard I'm used to is chapter 1, chapter 2, chapter 3 methods, chapter 4 results, chapter 5 what do you call discussion, and maybe at PhD level, in some cases, you may even go up to chapter 6 or 7.
Yeah. Okay, so I don't know if there are any other issues, and I'm not sure if Vivian, we have answered you, but if you are to look at chapter 4, maybe before we go, because for me, I actually prefer this chapter to be the last one to be written. And my thinking is, most of the times people write lies in chapter 3 before they collect the data, and I would want them to collect the data, do the analysis, probably even write conclusions, and then come back and report exactly how did they collect this data. Yeah, of course, I have seen, because people would write they have administered questionnaires when they haven't, and it becomes problematic for me. So I always advise my students to go collect the data, skip chapter 3, write, analyze the data, make the conclusions. Then when you are tying up your dissertation, come back and write the methodology chapter. As long as you are making some field notes in the booklet, you should be able, because I really want the methodology chapter to be a chapter where people report the truth about how they went about the study. And I don't know, and I'm always saying people should do like what I'm doing. It should be written last, so that you are in a position to say, I also did that for my PhD. I wrote my methodology chapter at the same time I was writing and completing my first chapter.
Yeah, I just want to come in there. I think, yeah, I think it's the best route actually is to write it the last. When you are actually writing, the 2 chapters that should be written last for me, it's always the chapter that deals with the methodology, and the first chapter that summarizes everything that that you did, or what the study is all about. Those 2 chapters must always be written last. But if you can't use that route, write chapter 3, but know that it's a draft. Just know that it's a draft. Yeah. Whatever it is, it's a draft until you have done everything that concerns that particular study, and then you can then revisit it and make sure that you plug all the holes that you have not you have left uncovered. So it's very important that you do that. You write it last so that you can be able to capture exactly how did you go about carrying out the data collection, how did you analyze the data, what are the ethical implications that you had to overcome to come up with that data set. You need to report that last, otherwise you'll be lying to people if you write it in the first instance, because at the end of the day, it becomes how do you know what exactly you're going to encounter in the field before you get into the field?
Yeah, so I think we are coming to the end. Perhaps maybe people who always attend here, they might need to suggest perhaps what do they need to listen to. Then maybe we can focus our discussions on that. Are we doing mixed methods next week, Dr. Mare?
Yes, I think for me, the mixed methods or sampling techniques depends. I think sampling techniques, I think it requires its own space where we talk about both probability and non-probability sampling, what really is involved, so that people will probably be able to understand how to use these sampling techniques, and then probably then deal with the mixed methods, whatever comes first. But also, I'm also open to suggestions from people that usually attend this so that we can deal with their concerns too.
Yeah. Yeah, I think so. So if any one of you have got concerns, I think you can drop me an email so that it informs our next level of meetings, so that we know which aspects do we need to address, and then we move forward. So without further issues, further aspects, I hope you have benefited from this discussion, and we hope to meet again next week. So it's bye-bye for now.
Thank you.